Start now. Good morning, everybody. Welcome to another wonderful morning of chemistry with your host, Dr. White. Now, as I just mentioned, I have removed the answers for the balanced chemical equation lab. If you need to see them, come to my office hours on Monday and Wednesday night in Zoom. All right. Let me remind you again, tomorrow at about 8:30ish or so, I'll send out an email with the password for test two, and the PDF file. Instructions how to do test number 2 are already in Blackboard in the assignments area for you to download at your leisure. I'd recommend you do it now to make sure you don't have any problems. And then tomorrow, I will be sending out the password in an email, and you'll have until 9 a.m. Friday morning, take the test, copy the answers, send them, upload them to Blackboard. There are a couple ways you can make the PDF file. I have that all in the instructions for taking a test. And please don't cheat. I have secret things in there, which I know if you cheat, and I will do what's in my syllabus if students cheat. I'm pretty laid back, but there are two things that get me upset. You never want me upset. One is people who lie to me, and two, students who cheat. Cheating is just another form of lying in my mind. But anyways, don't, so please don't. Keep Dr. White happy. All right. Another thing, this little good news on the sideline. I happened to look at the schedule where we are in lectures and everything, and we're right on track. Things are going good. But I do have something sad to tell you. I looked at the calendar, and after today, there's only 22 more days I'll have with you. I've been having a good time this summer. Hopefully you are. Time flies when you're having fun with chemistry. All right. With that, let's get to work. Now, I was talking about the ideal gas law. The ideal gas law is PV equal nRT. P is pressure in atmospheres. V is volume in liters. And on a problem, I'll always give you volume in liters. I'm not going to ask you to convert from milliliters to liters, even though I know how to do it, but I won't. N is the number of moles, but you'll be given it in grams, and you have to convert grams to moles. But hopefully you've learned that for tomorrow, test number 2. Ooh. Important commercial or public service announcement from me, your host, Dr. White. Tomorrow on the test, when you take it, or tomorrow night, whenever you do, don't forget, use your good buddy, your good friend, unit analysis. It will help you. Also, it helps to show your work. You don't have to, but if you get the wrong answer because you pushed the buttons wrong on your calculator and you don't show your work, you get 0. That's a big 0. If you push the buttons on your calculator wrong and put down the wrong number, but show your work and that's correct, if it's, say, a 10-point problem, only take 1 point off for math error. Also, don't forget to use proper significant figures for all calculated answers, and use 3 significant figures for all atomic masses. It's on the test, but I'm reminding you again. All right, let's get back to, let's see, the Labster that's due tomorrow, and I have a question from one of your colleagues. The Labster, because we've all had a lot of fun with Labster. Don't tell anybody I just said that. But anyways, I'm being a lot more lenient than I normally would be if we were in a lab at COD, which I would if you don't hand it in right, take off points for Labster. Just get there, answer at least one question. I know some of you are having problems. say you've done that, but when I look on Labster, I have what's called a dashboard, and I don't see have done anything. We'll work it out. Trust me. I'm not that kind of teacher saying, "Ooh, how many points can I knock off a student?" I don't do that. So, but anyways, the Labster lab that is distillation of ethanol. Just get in there, try and answer 1 or 2 questions, and you'll get your credit. Hopefully that answers your question. And Andrea, you're welcome. All right, let's get back to PV equal nRT. N is moles, which you normally will give it, not normally, always are going to get a weight, grams, that you have to convert into moles. R is the universal gas law constant. And for this class, use 0.0821 atmospheres liters per mole K. This is a calculated number, not an exact number. And for my class, I use 3 significant figures. Finally, T is temperature. Every thermometer I've ever seen in science has been centigrade. I've never seen a Kelvin thermometer or digital readout, which in plants and in labs I've used. And therefore, you have to know how to convert from degrees C to Kelvin. I will put that all in important information when we do. Remember, this is for test number 3, which is a week from tomorrow. I think looking back, I was thinking about it this morning. I think it was a great move on my part. Thank you, Dr. White, that I postponed the test number 2 by 1 week. But what that means is every Thursday this July, I'm giving a test or a final. Oh, by the way, you can all make angry faces at Dr. White, but I think that will help you do well in my course, which is really what I want and for you to learn. All right, so PV equal nRT, ideal gas law. And how do you know you're doing a PV equal nRT problem? You'll have a gas and you'll see none of the variables change. In Boyle's law, either the pressure or volume. I'm not asking you to learn Charles' law, but this is PV equal nRT. Don't forget, I talked about in the winter when the temperature goes down, the pressure in your tires go down. So you should check them if it gets real super cold. In the summer, if you notice the forecast starting to get warm out there, Dr. White doesn't like summer. I like the other seasons, not summer. It's too hot. But anyways, in the summer, especially it gets super hot, your temperature in the gas in your tires go up, and therefore your pressure goes up because the volume, the number of moles are always constant, and R is a constant. So if temperature changes, the pressure is changing. And this is PV equal nRT. Let's have some fun with that. But before I do that, I just remembered tomorrow's lab, I have on my syllabus, the ideal gas law or law ideal gas, which I didn't see in Labster. I wonder if they just deleted it because it was so, how should I say, awful. But anyways, what I will be doing is sometime today, I'll finish up, and either today or first thing tomorrow morning, I'll post for tomorrow's lab, my own lab with PV equal nRT. I've got it about half done. It'll be really nice and you'll learn about it. And I also found a good YouTube. All right, let's have some Dr. White fun with PV equal nRT. You can have fun with that? Of course, if you're a chemist. I haven't checked with you. I did, but let's do it once more. Thumbs up, people. Can you see my whiteboard with the pens? Thank you. All right, let's have fun with PV equal nRT. Hang in there while I'm writing this. All right, let me read it. 15 points. Ooh. If you burp 2.50 grams of carbon dioxide, CO2, at 22 degrees C and 758 torr, then what is the volume of your burp? When you burp, most of what's coming out is carbon dioxide. I bet you never thought you would hear about burping in a chemistry class. Well, you are. All right, I'm going to make you work a little today. And what I'm going to ask you to do first on your own is figure out what are you being asked to find, and figure out what you're given. That's all I'm asking right now. Look at the problem, answer, or write down, you see me do it, what are you being asked to find, and what are you given? That's all. I'll give you a minute to do that. Go. Hurry up, the clock is ticking. If I had my hearing aids in, I could hear it. No, I don't have any clocks that tick anymore. They're all digital. Again, I'm not asking you to solve the problem. Just figure out what are you being asked to find and what are you given. When you've done that, look up and smile if you were in, or give me a thumbs up. All right, I think everybody's done with the first thing. And the question is, what are you being asked to find? Wrong pen. Right pen. Volume. What are you given? This. You're also given the temperature. And it's important to put the units. And you're given the pressure. Now, if you notice here, nothing's changing. You're not told this is the initial temperature, this is the final temperature, this is the initial pressure, final pressure. It's staying the same. And as soon as you know that, you should know it's time for the ideal gas law. Now, what are you being asked to solve for? V. I'm going to let you try just with the letters, solve for V. I'll give you 30.5 seconds to do that. Dr. White's pulling a winky dink on you. And after the problem, someone remind me to explain what's winky dink, or more importantly, who's winky dink? Well, I see some of you are going ahead and doing the calculations. Dr. White has a magic eye, can see out into the internet. Not really. All right, let's take a look at this. We want to solve for V, because that's what we're being asked to find. How do we get V alone when you're multiplying something times itself? Remember, anything divided by itself equals number one, meaning it's gone. So if I want to get rid of P, how do I get rid of it? I divide by P. But whatever you do to one side, you have to do to the other. This cancels out because of this. Therefore, I'm left with V equals nRT. But here's a common mistake divided by P. That's not a common mistake. That's, I forgot. Students will put these numbers in. No, they have to be the right units. P has to be in atmospheres. N is moles. And T is in Kelvin. And therefore, let's get to work. Pressure in atmospheres. I have 758 torr. I want to get to atmospheres. It's time to use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top the units. The other ones go underneath. In important information I will give you for test 3. I can write it. That's supposed to be mmHg. 760 millimeters of mercury equals 760 torr equal 1 atmosphere. Therefore, what units do I want on top? Atmosphere. What units do I want underneath? Torr. If I look up here, it's 1 atmosphere per 760 torr. This is a definition. Therefore, these are exact numbers, and these don't play a role. That's an awful looking arrow. I can do better. Let's find out. These play no role in significant figures. 3, exact number, 3. And I cheated. I did the calculation ahead of time. And if you do it, let me write it down here, to 3 significant figures, that's what you get. Now, again, there's 2 ways of rounding off for a multi-step problem like this. One is at the very end, one is at each step. I'm an each step guy, but you can do it at the very end. Sometimes you get different answers. Both will always be correct on my test. All right, the next thing, since I started here, I'll go up the list, is temperature. Remember, temperature has to be in Kelvin. And therefore, temperature in Kelvin. But if you're given degrees C to convert it, you add 273. Degrees C for this problem was 22. Remember, for addition, you get the same number of significant figures past the decimal as the number that has the least. This has 0. This is an exact number because it's part of a definition. So the answer here is 295 Kelvin. The last thing we have to do is find N. N is moles. But oh no, Dr. White was cruel. He gave us grams. Why? Because I've never seen a balance in moles. If you know of one, let me know. They don't exist. So now I have to figure out N moles. And here, what do we have to start with? 2.50 grams carbon dioxide. What answer do I want to get to unit-wise? Moles. And now I get to use the red pen because it's time for unit analysis. You're a good buddy, you're a good friend. Whatever units you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. In this case, on top, I want moles. Underneath, I want grams of CO2. This is moles of CO2. And where do you get this? It will be on test number 1, 2, and 3. 1 mole compound equals the molecular weight in grams of the compound. And where do we get that number? Carbon dioxide has 1 carbon, 2 oxygen, 1 times what? The atomic weight of carbon. Where do you get that? Hang on to your seats. We're switching screens. That was a lame joke. And if you notice right here, underneath the letter C, carbon, you see 12.011. Round that off to 3 significant figures. That's 12.0. We'll need oxygen. Here it's 15.999. Round that off to 3 significant figures. That's 16.0. So I come over here. I have carbon at 12.0, 2 oxygen at 16.0. Add it up, and you get 44.0. Both of these have 1 past the decimal. When you add, you have the same number of significant figures past the decimal as the number you're adding that has the fewest significant figures past the decimal. In both cases, it's 1. That's why I get 44.0. Tea break. Oh, is that good? And therefore, 1 mole equals the molecular weight, in this case, is 44.0. Grams cancel out. If I do the math, which I did ahead of time, hold on. Let me get to my calculator because I thought I wrote it down and I didn't. And the number you get is 0.0568 moles, or 5.68 times 10 to the minus 2. You can do either one. and therefore we have this. Now, if we go over here, we have V equal nRT over P. I'm writing it down again so you can see it. N is 0.0568 moles. R is 0.0821 atmospheres, liters, mole, K. Sorry, I made it so small, but and this is 295 Kelvin divided by the pressure, which over here is 0.997 atmospheres. And if we look over here, moles divided by moles cancel out, Kelvin divided by Kelvin. So this thing right here is gone. And up here we have atmospheres, liters, atmospheres cancel out, and we're left with liters, which is what we're trying to get. And if you do the math, and hopefully I copied down the right number, you get 1.38 liters of CO2. So if you burp 2.5 grams of CO2, you're gonna burp for a long time, because I think your normal when you exhale totally is only about 2 liters. If you try and blow as hard as you can to empty your lungs out, your lungs, I saw last night, has, when I checked, has a capacity of 6 liters, but the actual capacity is 4.8, and there's a name, when you breathe, you're only doing completely breathing out your lungs, real deep breath is 2 liters. So if you think about it, have you ever seen the 2-liter bottle of pop? If you burp 2.5 grams, that's about 2/3 of a bottle of that of a burp. That's a big burp. And see, you can have fun with burps and PV equal nRT. But you never thought when you breathe going into your lungs, yep, I think they're there. By the way, watch out. Dr. White, the last time I had biology class was freshman year high school. Wow, that was too long ago. Not that there's anything wrong with biology, but by then I knew I was going to be a chemist, and I did. All right, any questions about PV equal nRT? Looking at the schedule, and I know we'll do it today, we'll finish the chapter on gases 11. On Monday, I will go through the gases practice problem set in class, or actually in Zoom. I guess you call it Zoom class, ZC, never mind. But anyways, I'll do that on Monday, so make sure you do the practice problems after you do the test this weekend. I'm gonna keep you busy. Every weekend this July, I'm gonna keep you busy. All right, let's move on. We've done our practice time. Actually, this is from when I'm we're in classroom now, I'd be see your monitor. All right. I'm turning the switch. This is on the test, click to the off position. But still something I want to just talk about briefly. And that is molar mass. And the ideal gas law, and the weight of a known gas, one can calculate the molar gas of the molar mass of a gas. Now, it turns out that was quite important to help chemists find out what's the mass of things like oxygen and everything else. click, switches on. This can be on the test. It will be. It will be, if you didn't catch that. And that's Dalton's law of partial pressure. And Dalton's law, which I'll never ask you in words what it is, but I'll ask you to know how to use it. The total pressure exerted by a mixture is the sum of the partial pressures of the individual gases. What's a partial pressure? Well, the partial pressure is the pressure that a gas in a mixture, would exert if it were alone under the same conditions. So if you had two gases in a mixture and each one you could isolate alone and measure the pressure that it's doing in that mixture, that would be the partial pressure. Now, Dalton's law, by the way, Dalton is English, if you haven't figured that out, is the following. The total pressure is the sum of all partial pressures. And this should be, know how to use this. Now, P sub n means if you have 4 or 5 things, 5 gases in a mixture, you'd add each partial pressure, P1, 2, 3, 4, and 5. And like this tells you whatever it is. If there are only 2, you just do P1 and 2. So let's have fun with Dalton's law of partial pressures. Changed my mind. All right, let me decode what I just wrote. And that is, what is the pressure of a mixture of argon and nitrogen gas? They are argon and 2 nitrogen gases. If the partial pressure of argon is 151 torr and the partial pressure of nitrogen is 101 torr, 3 to 5 points, somewhere in that range. So what are we trying to find? The total pressure. What are we given? The partial pressure of argon, which is 151 torr. What are we also given? The partial pressure of nitrogen, which is 101 torr. And this you'll be given. What should you use? Dalton's law of partial pressures, and that is the total pressure equals the sum of all partial pressures. In this case, that's P argon plus P nitrogen. And therefore, if I look over here, I took the time to figure out P argon is 151 torr. P nitrogen, partial pressure nitrogen, is 101 torr. And now I'm going to add this up in my brain and see if I can do it. I think I did it right. And this is your answer. And that's Dalton's law of partial pressures. Well, let's have some more fun with it. First of all, any questions on this? I'll let you copy this down if you're still copying it down. I get to drink some tea. And I've already had my vanilla almond. This is my blueberry. All right, let's do another one. I'm going to take a break and take spelling lessons. No, I'm not. Maybe I will. Time for me to do what's known in education is fading prompts. You do this all on your own. Have fun. If you didn't take notes, I'll help you out. Remember, when you're done, look up and smile. All right, looks like everybody, if you're done, give me a thumbs up. Oh, look, I see a lot of thumbs. That was pretty lame. All right, let's do this. What are we being asked to find? What's the pressure of a mixture of gases? That's called P total. What are we given? Partial pressure of krypton is 122 torr. Partial pressure of oxygen is 31 torr. P total, Dalton's law of partial pressure, equals, this case, the sum of the partial pressures of the gases in the mixture. That's partial pressure krypton, partial pressure oxygen, and therefore this is 122 torr. This is 31 torr. When you're adding, you get the same number of significant figures past the decimals. The number has the fewest. This is 0. This is 0. My answer will be 0. 152 torr if I did it. Oh, let's do one more. These are fun. All right, let me decode this. If a mixture of oxygen and nitrogen has a pressure of 642 torr and the partial pressure of oxygen is 202 torr, then what is the partial pressure of nitrogen? Couple things, this will be on test. Hold on. Let's try this again. Test 3, I will give you Dalton's law. This total pressure equals sum of partial pressures. One thing I haven't talked about this semester, remember, A minus A equals 0. That's one way to get at things when you're adding or subtracting. I'll let you try this all on your own. Go. See, some of you are already done sharing your answers. Those who aren't finished, don't peek. At this point, I look around and say, if you're done, smile. If not, since you were on video or not, give me a thumbs up. I see some thumbs up. Let's do this. All right. What are we being asked to find? We're being asked to find partial pressure of nitrogen. What are we given? P total. What else are we given? Partial pressure of oxygen. And as soon as you see partial pressure in a problem, you know that's Dalton's law of partial pressures. P total equal the sum of the partial pressures, in this case, P oxygen plus partial pressure nitrogen. We're solving for this, so we want to get rid of this. How do we do that? We use this, and that is P total on this side, but I'm going to leave a lot of room. You'll see why. If I want to get rid of this, how do I get rid of that? When you have an addition of two things, to get rid of one of them, you subtract. This minus this is 0. It's gone. Whatever you do to one side, you have to do the other. So I do. I'm going to rewrite this because that's Dr. White likes to. You don't have to. P nitrogen, partial pressure, nitrogen equals the total pressure minus the pressure, this is a P, ugly P, but it's a P of oxygen, and that would be 642 torr minus 202 torr equals, if I do the math correctly, 440 torr. And with that, I've gone a whole minute over. So let's come back at 2 minutes, 9:58. Why don't you come back? We'll take a 5-minute break. Five, come back at Well, it's 9:57. I didn't add right. And I'll see you in 5 minutes. Time for Dr. White to do his stretching exercises. I'm back. I stole that line from Independence Day movie, if you've ever seen that. Speaking about Independence Day, and I'll say it tomorrow, but I'll say it again, coming up this weekend, the 4th of July. Have a happy 4th of July. Stay away from any fireworks, stay away from any crowds, and stay away from any parties unless they're on Zoom, so you can stay safe and healthy. As I say, gay and gesund. If you've been following the news, the biggest increase in people being infected by COVID-19 is the age group you're in, and that is 18 to 35. Why? Because in a lot of states, I don't know about Illinois, people went out to bars and restaurants in big crowds, went to beaches, and got sick because they didn't also have masks like in Texas, Florida, and Arizona. Wear a mask that protects other people around you, like Dr. White, and it also keeps you safe, and do social distancing in spite of what the person in the White House says. All right, enough of politics. All right, let's take a look at where we were. We did Dalton's Law of partial pressure. Now, switches off here. One place to use Dalton's Law, if you collect things gas over water, if you have a bottle of water or glass above that, there's some water vapor. Vapor is a term for a gas that's of a substance that's normally a liquid at that pressure, and use Dalton's Law to compensate for that. This will never be on a test or final of mine. And you can use the gas laws in chemical reactions. I won't do this. Switches off on this one. Now, switch is still off. There's something called STP, which is not the oil additive, but it's called standard temperature and pressure. And in chemistry, that's 273 K, 1 atmosphere. Now, it turns out, and again, the switch is off here, at STP, 1 mole of a gas equals 22.4 liters. And this is what Avogadro discovered, which is why his name is associated with Avogadro's number, even though Avogadro's number was discovered by 2 Germans who, after I found that out a couple of years ago, they really should have been credited. Avogadro could have been given something else, but they didn't. And with that, oh no, you look at the lower, hold on, lower corner here, you see page 24 of 24. And you know what that means? We're done with this chapter. And you know what else that means? Oh yes, it's time for, it's a new chapter time, new stuff time. And what's that new chapter? That new chapter or material is solutions. And solutions, it turns out, is an important part of our life. See my tea here? What's left of it? Hold on. That's a solution. Now, hopefully you are all breathing. I hope so. And when you inhale, the air all around us, oh, that looked nice. The air all around us, by the way, it's only tea. Dr. White loves chemistry and has a lot of fun with it. The air all around us is a solution. You don't think of that, but it's a mixture of oxygen and nitrogen. The question is, what is a solution? And a solution is a homogeneous, that means it's the same throughout, combination of 2 or more substances in which each substance retains its own chemical identity. In other words, when you mix 2 things together to make a solution, they don't react with each other chemically. And so air is a solution. Now, when we talk about solutions, there are 2 important key definitions you should know. Hold on. It's time for Dr. White to be subtle. And I'm being subtle. All right, when you have a solution, you have two components or two definitions. One is the solvent. By definition, the solvent is the component of the solution that's present in the greatest amount. The solvent is the component of the solution that's present in the greatest amount. All other components are called solutes. You can only have one solvent, but you can have many solutes. A solute is a solution component that is present in a small, or actually should be smaller amount relative to the solvent. Solvent, always present in the greatest amount. Solute or solutes, all the other components of a solution. Oop, wrong color. Now let's take a look at the following. I haven't asked about you people yet. Thumbs up, people. Can you see the problem on the screen? Thank you. You guys are the fastest thumbs up people on the planet. All right. If you have a solution containing 100 grams of water and 5 grams of sodium chloride, table salt, then what is the solvent and the solute of this solution? Well, the solvent is always the component in the greatest amount. So the answer would be solvent is water. What is the solute? Well, the other components. In this case, it's only salt. And that's how you do. Oh, this is fun. I've got to share the fun with you. By the way, I might even make that 4 points. Time for me to decode what I just wrote so you know what I'm talking about. If you have a solution of 70 grams of a chemical called isopropyl alcohol and 30 grams of water, then what is the solvent and what is the solute of the solution? Your time to have some fun. Go. At this point, I'd be telling the class, if we were in a classroom at COD, when you're done, look up and smile. But I'm going to have to ask you to use the thumbs up because not all of you have your video turned on or not all of you have web cameras. But you can still enjoy chemistry with your host, Dr. White. All right, I'll give you another 10.2 seconds. Go. 2, 3, 4, 5, 6, got a slow clock, 7, 8, 9, 9.2, 9.6, 9.825. Time's up. Let's take a look at how do we do this. Remember, the solvent is the component present in the greatest amount. And I hope you all agree 70 is greater than 30. So the solvent isopropyl alcohol. All other components are solutes. In this case, we only have one, water. Now, most things in our daily life, not all, but most, the solvent of a solution is usually water. Now, in this case, it's different. It's isopropyl alcohol. Now, one of the things I've told you, I'll be getting more into the real life now that we're getting into the juicy stuff. What's a mixture of 70 grams isopropyl alcohol, 30 grams water? Well, you can go to your local big box store like Target or Walmart or anywhere that sells it, and you can buy a bottle of that solution. They have a name for it, and it's called rubbing alcohol. And about 5 years ago, they also started making rubbing alcohol where you can get up to 90 grams of isopropyl alcohol, 10 grams of water. And that's a good thing. That's a good disinfectant, which means I hope they got it back in stock. I've always kept some in my house, so I always had it before COVID-19, but it's a good disinfectant. The 70-30 isopropyl or rubbing alcohol is a very good disinfectant. Time for Dr. White's story. Do I have time? I do. And that is when I was younger, before they had the digital thermometers that you put in your mouth, they had the mercury thermometers in the doctor's office. And if you went in there, the first thing the nurse always did was shove the thermometer under your tongue to get your temperature. Well, they were always kept in a V-shaped container. Why it was that way, I don't know, but it was, and there was a liquid in there. And that liquid was rubbing alcohol, 70 parts or grams isopropyl alcohol, 10 parts water, because it's a very good disinfectant, kills all the germs from the last patient. They'd wipe it off, stick it in your tongue, under your tongue, but it still have some of the isopropyl alcohol. It tasted but it was better to taste than get sick from somebody else's germs. But that's rubbing alcohol. So if you're wondering why you're learning about chemistry, all you have to do is go to your big box store and you'll see. I see I have a question. And yes, I see someone called sanitizer is another synonym. Ooh, Dr. White's using big, expensive, fancy words now. Synonym for antimicrobial or antibacterial. And that's one of those. The other one is if you have mixture of ethanol and water, they're both alcohols. So if you take my organic chemistry, which I'm not teaching this semester at COD, but I am teaching if you need organic chemistry at Elgin Community College, it'll be totally online. Take it. Ooh, a commercial from Dr. White. All right, so now you know what a solvent is. Solvent, the component of a solution that's present in the greatest amount. Solute, the solution containing the components that is present, and this should be really smaller amount relative to the solvent. Now, when we have solutions, most people think of liquids as solutions. But as I said, oxygen, which is a solute in air, nitrogen is a solvent. Also, what's a solute in air? If you go outside today, it's really humid. That means there's a lot of water vapor or water molecules in the air. That's it. Now, liquids can be very complex or simple. You can have salt and water, I talked about. Now, pop, I should mention, Dr. White is from the Chicagoland area. I was born and raised here. The only time I didn't live here is when I went to grad school in Michigan, at Michigan State. Go green, go white. But anyways, stuff in a bottle, plastic or a can, that's carbonated, non-alcoholic, we call like 7-Up, Coke, or Dr. Pepper, I like, or Verner's. If you haven't had Verner's, go to Jewel and buy some. It's great. It's a very highly carbonated, spicy ginger ale that I love. But anyways, I call that pop, and if you're from the Chicagoland area, you call it pop, you don't call it soda. But pop is a very complex mixture. Look at the label, you'll see water, sugar, flavoring, and it also has a gas mixed into it, and that's carbon dioxide. And that's what gives the little bubbles. It makes it taste so much fun, at least for me. And when you go to the gas station, gasoline is a mixture of gasoline, which is, I really should have put octane, and ethanol, which is an alcohol put in there to help make your engine run better. Now you can have solid solutions. I said mixture, just really, I should have said solution. Your dental fillings used to be, when they're mercury amalgam, is a mixture. Sterling silver is a mixture. And there are other things too. Now, when we talk about solutions, an important concept is the solubility of a solute. And the solubility of a solute is the maximum amount of solution that will dissolve in a given amount of solvent. And that tells you how much you can put in a one chemical into another. Now, let's have some fun. One of the things I think I've mentioned more than once, Wikipedia, when it comes to chemistry, is about 99.9% always correct, because it's policed by people like myself. Yes, I have the credentials to request and get changes made. Now, if you look at any chemical in Wikipedia, on the right, and let me do a thumbs up. Everybody see the internet? Thank you. You guys are the best. You'll see identifiers, then you'll see properties. You learned about physical properties for sodium chloride. Please pass the NACL. It has the molecular weight. And notice down here, it has solubility in water and ammonia and methanol. I don't know why you would do that. But if we look at here, and we can dissolve the solubility, the maximum amount you can dissolve is 360 grams per liter. L is liter of volume. And let's do one more just for the fun of it. And what you don't know, but Dr. White does, sucrose is the common chemical name for what you call table sugar. And if we scroll down, we see properties, and we see its solubility at 25 degrees C, and I'll explain that in a little while, is about 200 grams. So the sugar is less soluble in deciliter, that's 100. Actually, I take that back. This is 2,000 grams per liter, so it's more soluble. Let's look at the table that I have it down here. I don't know why they didn't put liter. That's stupid, but I'm not going to ask for a change. And so sugar is more soluble in water than sodium chloride. So if you want to make a sugar solution, if you want to sweeten up your life, go right ahead. Put a lot of sugar in water and have a drink. But solubility is an important concept you should understand. That's the maximum amount of solute that will dissolve in a given solvent. Now, as I mentioned when we saw that table where they had temperature, I won't ask this on a test, but you should know factors that affect solubility, how much of a solute you can dissolve in a solute of a solution. What are you trying to dissolve it in will affect it. The temperature, cooking trick, when you want to get sugar to dissolve faster in water, you heat it up a little. The solute, what you're trying to dissolve, are there other solutes? And even the pressure is sometimes a factor. All right, switch is on now. There are a couple definitions I would like you to know. The first one is saturated solution. A saturated solution contains the maximum amount of solute that can be dissolved under conditions which the solution exists. In other words, when you have thank you, Creative Cloud, hold on. When you have a saturated solution, you can't put one more molecule in because it will precipitate out, form a solid. If I had a saturated solution of sugar in here, I don't, it's just water, and I put one more molecule or two of sugar in here, it wouldn't dissolve, it'd fall right to the bottom and you'd see a solid form. And that means when it's saturated, I have reached the limit of what I can dissolve in that solvent. By the way, you now know what a solvent is. Now, another definition is a dilute solution. A dilute solution contains a small amount of solute relative to the amount that could dissolve. So if I have a dilute solution, I just put a small amount of solute in that solution relative to the amount that could dissolve. Back when Dr. White was younger, long time ago, I was in a bar in Chicago, and some bars, if you've been in bars, they water the drinks down. They don't give you enough of the liquor that's in there, ethanol. I got a watered down drink. I could tell it was watered down. And I said to the bartender, you know, this is pretty dilute. And he gave me a look like, if you don't like it, you can leave. And I said, it's still pretty dilute. And I drank it. And then I left with my friends because they were watering down. By the way, bartenders don't like being taught chemistry. They don't. Even though I did have over the years a couple students while taking my classes were bartenders, or I guess if you're a woman, is it bartenderess? Whatever. Anyways, that's a dilute solution. Now, the opposite of dilute solution is a concentrated solution. Now, concentrated solution means you have a large amount of solute relative to the amount that could dissolve. You're not at saturated solution. You can still put a little bit more in, but you still have a lot of the solute in. And concentrated solution means there's a lot of solute. And it's not as popular now in the supermarkets, but I'm going to ask a quick quick thumbs up. Everybody see the orange juice? Thank you. You can buy orange juice, most people nowadays, and I'm not a big orange juice person, never have been. You can buy it already made up in a big container that you just pour into a glass. Now, when I was a kid, that wasn't being sold. What you bought was called a concentrate, which is a concentrated orange juice. That means the actual chemicals from that make up that taste were in a high concentration relative to what the solution is. And the solution means there's less water. It's higher concentrated. And that's where the word concentrated orange juice came up, because it's a concentrated solution. Now, true story. When I was in college, I was in a fraternity house. Maybe someday I'll tell you some wild stories about my fraternity. They actually made a wild movie about my actual fraternity house when I was there. We had wild times. But one of my fraternity brothers had some unique eating habits. And one of the things he loved to do was eat concentrated orange juice right out of the can with a spoon. But oh, by the way, we gave him a nickname. His nickname was the Beast. I won't tell you what mine was. My lips are sealed. But that he was eating concentrated orange juice. So you should know concentrated solution, you have the maximum amount of solute present, or not the maximum, a large amount of solute present relative to what you could dissolve. Now, this is really important. You should know an aqueous solution, which comes from, derived from the Latin word aqua, water. Aqueous solution means it's a solution in which the water is a solvent. So anytime you have a solution where the water is a solvent, that's an aqueous solution. And I'll be teaching you later on this chapter, how do you know it's an aqueous solution? You'll see the letters bracket, AQ, close bracket. That's a better Q. And this means you have an aqueous solution. Aqueous solution immediately tells you the solvent is water. If I tell you I have an aqueous solution of hydrochloric acid, what do you know? The solvent is water. Now, another term you should know is non-aqueous solution. And non-aqueous solution means it's a solution in which the substance other than water is the solvent. And in organic chemistry, we use a lot of non-aqueous solutions. Most of my research as a grad student, I worked at chemistry and solutions, mixtures of chemicals that were always non-aqueous, because water would immediately react with what I was trying to do and not let me do what I was trying to do. And that's non-aqueous. All right, this part switches off, click, but still something I want to mention briefly. When you form a solution, you have, say, sodium chloride. When you look at the table salt, that's molecules of sodium chloride held together by interactions. We call those polar interactions chemical bonds. And the solvent, like water, is held together in a liquid, and those interactions we call hydrogen bonds. And when you mix the two together, you have to break the solute-solute attractions. They have to be overcome. The solvent-solvent attractions have to be overcome, but you form new solvent-solute attractions. Again, switches off for this. Factor switches off. when you're dissolving one thing in another and making a solution, are you talking about powder or large pieces if you're dealing with a solid and a liquid? How well do you mix it? What's the temperature of the solution? Those are all variables chemists can use to help make solutions quicker. All right, I'm going to do something. I'm not going to touch this right now because I don't want to run over time. I don't want to rush through this. So I see I have a whole minute and a half, so I better preach to the choir. Make sure you're doing the practice problems today for the test number 2. Make sure you go look online. I have my test number 2 review there. You can also look at yesterday's video to see that. That will all help you. Because I think I told you, Dr. White is a very selfish person. I like things happening around me that make me happy. And therefore, you know what makes me happy? Seeing students do good on a test. So in order for you to do good on a test, again, try some of the practice problems and don't forget, look at the review. I don't think I mentioned this, but it's always true. Anything Dr. White puts on a test, any question, the concept behind that question, I've discussed with you at least twice, usually more than twice, but at least twice. I will never put anything on a test other than what's your name, because I don't practice what's your name in class. But other than that, I will never put a question on a test that I haven't talked about at least twice. With that, I'm going to let you out a whole 5 seconds early. You have a great day. Gain gesund, be healthy, and don't forget to study for tomorrow. And with that, bye.